difference in the world. So, like the mission was really the first part that interested me. But then pretty quickly I realized that people here were not afraid to look at crazy things and solutions that most other companies would discard as like insane. And I thought that was really interesting to be able to go far into a crazy idea.
Cool. Well, I guess we'd love to hear a little bit more about those crazy ideas.
Yeah.
Maybe before we dive into some of the prototypes behind us, can you tell us a little bit about, why you need a droid and what I assume is your crazy idea that you're referencing?
So when I joined, the idea that existed was a large vehicle that we keep high up and a smaller vehicle that we keep that allow us to do precise deliveries. And the main idea behind it was that we didn't want to have the large and slightly larger vehicles to go down into people's personal space, fly with like giant propellers at human height. And the idea behind the smaller vehicles that is able to deliver more precisely was that we didn't need it to land that larger vehicle and waste energy to also go back up. But also, most of the time, we would have had to drop a package from, let's say, 8 feet high, which is a little bit disrespectful when you order something for yourself and you're expecting a precise delivery.
And so what's next?
So this is one of the first, and when I mean one of the first, you're going to see a bunch of prototypes. We destroyed a lot of them, so that's one of the survivor. But one of the first configuration from engineering of what we thought could work. As you can see, it's made of cardboard and wood and 3D printed parts. Tristan and Zoltan at the time from the engineering team worked on this. We flew it. We tried to do housing around it to see kind of like the minimum volume that would take from, like just a volume standpoint. And it was pretty clear that it was not going to be the right solution.
Why?
So the main issue was the approachability. Like when you design something that doesn't exist, you have to be careful about the mental image that people will associate with a new product in general. So you want to associate a mental image that is more like reassuring and friendly, especially if you are entering people's personal space. And so, having two giant fans that you have no idea of any sense of orientation or that could come at any time close to you is not something that was preferred. So we looked at a lot of configuration, and these are just some of the few sketches, but literally some of the first sketches that we did around configuration. And
wow, look at that. So different.
You will see like a lot of them, like we looked at everything, the way we can steer it, the way we can, actuate it and stabilize it. And, from that standpoint, yeah, we looked at really a lot of ideas. This sketchbook is about 3 months worth of sketches.
3 months with this.
And we have a lot of
Well, what's the design process? Like, do you start with the sketch and then you do these types of prototyping?
Yeah, so I think one of the big differences at Zipline is that they approached me really early on in the project, so I was lucky enough to work really closely with the engineering team and work with them onto like the layout configuration and also like what it will take internally to get this working. So that way we were able to really optimize what we were going to do with the droid and with the Zip as well, because there was no like real surprise of like, oh wait, we have to put that giant thing here or that kind of thing there. So we designed it on a system level, which includes the vehicle, the droid, the Zip, which is a larger vehicle staying up, and all the infrastructure that allow us to interact with the droid and land and charge.
And having a propeller or 2 propellers on either side of the droid, I know this is not the model that we use, is really interesting. Why did we design to have the droid to have propellers on it?
So, well, yeah, we eventually thought about initially steering the droid, by just modifying the surface to kind of be able to steer it as it's going down. But we really wanted to be precise about where we want to deliver, and so ultimately the goal was to be able to deliver on a picnic table, which we are able to do now. So having the smaller vehicle being able to move into 3D was really something we wanted for that level of precision.
Let's talk about this one.
So this one was, at one point we looked at the idea of having our own Zipline packaging that people could load, and then the droid would be mostly that smaller configuration that flies away and let this packaging there. But it was clear that it was not the solution because one, we didn't want it to be wasteful in terms of leaving a larger packaging for potentially a really small shipment, and then forcing people to use a specific packaging versus what they are used to do. We didn't want it to disrupt the flow of their day-to-day business.
Yeah, that makes sense. It's cumbersome, and there's already packaging, so why add additional?
Exactly. We wanted to avoid a packaging within a packaging within a
Tell me a little bit about this sketchbook here and this sign that says fish.
So this is kind of forward in time. So what I was talking about, the configuration with the two propeller facing you was a little bit scary. So we looked at and we evaluated what it would take to actually be able to have the propeller in the back. And what came to mind pretty quickly with that configuration is, since we move in 3D, the mental association that was really a clear winner for this was a little aquatic animal, sea mammal or a little submarine, mostly because I think from a mental standpoint that's something that everyone recognizes, and that's also something the sea mammal are most of the time extremely friendly. They are really rounded in shape, so they, it's no part of a dolphin that looks scary. So, taking the inspiration from that to be able to be more approachable, and then the proportion of the droid in general are kind of inspired by the belly side of this animal, which tend to be a little bit small and chubby and really cute overall. So, I'm talking about cuteness. So, this one was an engineering model based on that configuration for validation that Tristan worked on. And as you can see, it has little flappy wings on the side. And what happened is when we were going down, he was actually lifting these wings for stabilization because we're fairly flat bottom. And we thought it was super cute, to have something like this coming in your personal space. So we were okay, this is great. The idea of staying cute and having an aspect of an animal was something reassuring for people.
Cool. I definitely feel I see the animal in this, which reminds me a little bit about this image right here.
Yeah, so the pawpaw is always a difficult word for me, but the shape of it, and we determined pretty quickly that we needed some fit as well to provide clearance for the door to open and be stable on many different type of surfaces. So this droid was a droid that we use for validation of the way to load it, which we load from the top and we deliver on the bottom. So we were able to test with this quicker than it would have taken to 3D print something of that volume and able to test different things, different functions of the droid as well.
And this, in addition to just being cuter, solved a lot of problems that brought up, is that right?
Yeah, so the little flappy wings were cute and everything, but they were kind of more complicated. So we always try to simplify solutions.
Yeah.
So usually, if you can remove a mechanical parts, one is less weight, two, it's something less that could be problematic. So the way we solve this is the bottom of the droid, and this is a faceted version, but the bottom of the droid is also the bottom surface of the zip, which stay in the sky. So both of these surfaces, from an industrial design standpoint, were pretty challenging because it needs to work on the droid and it also needs to work on the plane. So it serves dual function, and that roundness also provides us stability similar to the real flappy wings, just from a surface.
That makes a lot of sense. What's this one?
So this one, this one is, as you can see, prototype number 22 of that form factor. So it was more than 20 prototypes before this one. We had more than 22 prototypes of this specific configuration. But it was used for validation and evaluate the surfaces and like the performance overall of the motor that we use. And it's also like you can see it's like really close to the final drawing. So,
Right, because this is the final.
yeah. So this is still a prototype, but it is the final form factor. As you can see, we have like debris guards. Like the lid is extremely easy to open. So, and that's the part with the droids that was really interesting to me from an industrial design standpoint. Is usually products need to be designed for specifically one user, and the droid is actually designed for two different type of users: the people who are going to load it, regularly during the day, so they're going to interact with it, they're going to open it, close it. That's all they need to do. So trying to reduce the frustration from that standpoint. And also the second users are the people who are ordering a delivery, and this is entering their personal space, like I was mentioning. So they will not physically interact with it, but they will see it visually and interact to a way which is, like these things what they deliver their personal gift.
And can you tell me a little bit more about it? Like, I know that there's some additional volume.
Oh yeah, so from a loading standpoint, humans tend to overstuff things. I think we all went through the exercise of sitting on our luggage to get it to close before a flight.
That's what I do every single time.
So, loading a box is really easy because that's something we do almost every day. So, loading from the top and delivering from the bottom, like it took us a while to make sure that was the configuration we wanted. But ultimately, that's the easiest way to do it from a loader standpoint. So from that standpoint, since people overstuff things, the top of the lid has a little bit of that payload bay volume inside. So if someone do tend to overstuff that payload bay and the stuff puffed up, the volume will fit in the lid. One other aspect of this as well is like the top opening of that payload bay is actually smaller than the lower area. So the natural direction for delivery, if something is really large, it's going to want to drop down. And so, the approach of loading the droid as well was really from the standpoint that we didn't want people to have to go and crawl underneath like the zip, like the plane close to the propeller to load the payload.
Yeah.
We wanted to bring what we can load directly to the people, so we don't impact their other day-to-day work duties or their workflows in general.
Makes sense. I mean, I would love to learn a little bit more. I'm sure everyone at home would love to learn a little bit more about how the droid is actually loaded. Should we?
Yeah, we can. So we can walk to that model. So this is a scale model of Zip restaurant, and the idea there is that we can show, and if you can follow me, for example, we have like a 3D print here of what allows us to integrate with a building. So you have a tower on the side, then we have a barrier guard, and then the droid will descend in this sliding tunnel here, and will enter the building through an opening that is similar to a window. And the reason behind this was that we wanted people to not have to step outside, especially if the weather is not, helping, if it's raining or if it's snowy or if it's dark, we want it to be able for them to like load it directly from inside, so they don't disrupt also all the other things they are doing. And then this is our roof solution, which is one step higher. So we can land the zip over the building, and as you can see, also something non-conventional from anything that exists is we land upside down. So we arrive and we land vertically against the dock. And then we will drop the droid inside these doors that open, and it allows us to integrate directly. If you can come here, I will show you. So inside your restaurant, you might have, a small space behind the shelves where you could fit the droid and actually put your orders on this shelf and then load the droid directly from that spot, so you don't have to impact the other customers in the restaurants, or you don't have to impact the kitchen area with a cumbersome solution or having to come outside of the restaurant. We really want to make sure that the workflow is not impacted by what we do.
And there's a third loading option.
Yes, so the third loading option is the one exterior. So we could place that solution, and I don't have it to show it here, but like on a parking spot or on any flat surface, and be operational pretty quickly, since it's a structure that fold and install really fast.
How's the droid powered, or the zip actually?
So both the droid and the zip are charged on the dock that I was showing. So they are electronic motor with batteries, and we optimize the size of these batteries for the distance we need to fly.
Let's talk a little bit about the structure. Is this part of our design process at Zipline?
Yeah, so that was part of the great thing about being part of the project from the start. Is like if you have to develop a project that is that ambitious, you really cannot afford to not think about it from a system level. And then what I mean on system level, I think I mentioned earlier, is that you need to consider every impact of every decision you do on each element of what you are designing. So that way, everything makes sense together. And when I say this, by the way, I want to emphasize the fact that as an industrial designer, I don't do style. I like everything has a reason for it, and like the shape has a direction for performance, and everything is optimized for a reason, because since we are flying, we need to be as optimal as possible for weight, for the shape, direction of the shape.
Yeah.
So materials. Yeah.
That's cool.
Does that answer your question?
Yeah. So we make this, just to make sure I understand. So we make this type of structure to understand the system together.
Yeah. So everything works together. The zip lands this way, so we can drop clearly from the bottom. It's also way more stable to land against the surface than to land on the floor. You always see helicopter when they get close to the ground, they start to do this slightly uncontrolled movement. We don't have that because we land the opposite way. But yeah, everything works together, if I can summarize it in a simple way.
We obviously have a bunch of customers already. How do you go about designing a solution that integrates with their workflows? Like, do you visit retailers and health systems and hospitals and restaurants as part of your process?
Yeah, so here we are showing a restaurant, but good point, like it could be an hospital, it could be a pharmacy, it could be a doctor office. So we did visit a lot of other businesses, and something that was pretty clear early on was that a lot of these places, they do not have the luxury of having a room specifically for using our system. So by creating the portal, for example, which is the wall solution, we made sure that when you don't need to ship something, you just close the window and you reclaim that space again. This is not a space you lost. So if a droid arrives, you open the window, the droid arrives on the window, which becomes a ramp. You can load it. Yeah, you can see it in the back there. There's a small mock-up of it. You will see more on our website as well. But yeah, you load the droid that arrive on that window, the droid goes away, you close the window, and you reclaim your space, and you can go on doing the things that you usually do.
That's cool. So you visited customers as part of it.
Yeah, we visited a lot of customers pharmacies, labs, restaurants, medical centers, and we continue to visit a lot of different businesses.
Awesome. Is there anything else that you want to tell people who are watching this from home or the office?
I mean, I'm excited to continue, developing more ideas for this, but I'm super excited. You're gonna get fries that actually are not soggy or wet. You're gonna get pizza that is warm, and you're also gonna get medication really fast, or be able to order things, and by the time you walk outside, it will be on your table.
Yeah, and it saves you time.
It saves you time.
That's awesome. Well, Gregor, thanks so much for taking the time. We really appreciate it. You've been very generous with it. Thanks so much to everyone who's watching. Tune in next month for a look at how we thought about loading and the design of the loading process.
Stop it. I don't want that.